Hey guys, welcome back today. What I wanted to do today is go over some radical stuff because I've noticed when working with our special right triangles, doing the math to solve for the radicals is getting very difficult for us. And I want to make sure that we have a good base understanding of that before we really start moving forward. So to start off, I wanted to just do a couple problems. And these are similar problems that you guys will be working on today in class. And I want to make sure that you guys have that kind of figured out as we start to go forward. So when it says simplify a radical, what we want to do is get it to the simplest form. So we want to look for the factors to make sure that we can find a perfect square. So when we take a look at 1 and 18, we get 1 times 18, 2 times 9, and 3 times 6. All right, now all three of those give us 18, but only one of them has a perfect square. So what we want to do is we want to imagine that as 18. All right, we'll break that down into 6, the square root, square root of 9 times the square root of 2. So when you go through and do this, 9 is a perfect square, so we can say that's 3, square root of 2 as your answer. And that's kind of how you can work through one of those problems. Let's try a little bit bigger of a number. Let's take a look at 108. All right, so when we take a look at 108, we can start listing our factors, and we've got quite a few of them. It's a pretty divisible number, right? You start kind of working your way through it. And what we want to do is we want to make sure that we find the largest factor that is a perfect square. So when I start to look at this, nope, no perfect square. Nope, no perfect square. Yes, perfect square. Yes, perfect square. No perfect, well, yes, perfect square. Sorry about that. No perfect square, but that's small. That's small. That's our largest. That's not true. Let's go back. Let's start that over real quick. All right, no perfect square. No perfect square. Perfect square. Perfect square. Perfect square. No perfect square. So we want to find our largest perfect square. That's 9, 36, or 4. Well, that tells us that we're going to work with that 36. So we want to take that square root of 108. Kind of want to break that down into square root of 3 times the square root of 36. And once we do that, we should be able to see that this has become a 6, right? Because we take this out here, 6 times 6, right? And we're left over with that square root of 3. Now, sometimes you may come across ones that are already perfect squares like this one. What you can do is just take the square root of 64, well, 8 times 8, so that equals 8 as your answer. The next set I want to try is I want to try it with a couple different things here. I want to try with the 180m, and then the square root of 2 times the negative 2 times the square root of 2. And I want to kind of work through both of those real quick. So to start, we want to find the factors. Now, m is just kind of there. It's by itself. We can't do much for it. So factors of 180, right? Let's go 1 times 180, 2 times 90, 3 times 60. All right, still haven't really come to a perfect square. 4 times 45, and 5 times 36. All right, no perfect square, no perfect square, no perfect square, perfect square, perfect square. Our biggest perfect square is this 36 right here. So what this is this is 180 broken up into the square root of 5 multiplied by the square root of 36. And when we break that down, we get 6 square root of 5 as our answer. Now what do we do with that m? Because m is just there, that's not actually m times anything. So what we'd have to do is just kind of keep that m in that problem today. And that kind of stays the same. Now let's jump down and do this one. All right, square root of 2 times a negative 2 square root of 2. So when we look at this, right, what we have to kind of work through is we have to look and see what's going to happen here. So what we have to look and see, okay, well, I have a square root of 2 times a negative 2. Square root of 2 times a negative 2 is going to be a negative 2 square root of 2 times a negative 2 square root of 2. And you'd see that those end up kind of working in a way where the square roots will cross out, and that final answer would be 2. Now, as we get going, right, the next kind of set of problems is going to be a little bit different. I want you guys to basically just evaluate this, and that's not solve it. I just want you to really work on combining your like terms. So here is you know, one set, here's one set, right? Here's another set right there. And then that 7 is kind of off on its own. So an n to the third power minus 2n to the third power is going to give me negative n to the third power. A positive n plus a 6n, or plus a 5n, is going to give me 6n. And I can't do anything to the negative 7, so what I'm going to do is do that. And that's your final answer. So it's a pretty quick expression. You have to make sure you do the like terms. For example, when I look at this one, here are my like terms, right? So when I look at this, I have a 3x squared plus 8x squared is going to give me 11x squared. And I have a 2x to the fourth power plus an x to the fourth power, 3x to the fourth power, and then I'll bring down the 6. And I'm done. So nothing too difficult there today. The last step is going to be our multi-step equations. I know you guys like these a lot, so I'm just going to work through them. Negative 6, and then I have to distribute this out here. And once I start to distribute this, right, I get a negative 3 minus 21. And I'm getting ahead of myself here. Minus, let's rewrite this real quick. Minus 21b equals negative 9 minus 3b, because I didn't do anything on that side. Now I want to make sure that I combine like terms, right? And that's all I can do here, because you have to kind of remember that there's a imaginary line right here. That what I do on one side, if I want to do something to the other side, it kind of helps me break it up a little bit, and I can't do it. So what I get is I get a negative 9, negative 6 minus 3 more is negative 9, minus 21b equals a negative 9 minus 3b. So what I have to do next is I have to kind of get all of my b on one side. So I'm going to add 21b and add 21b. I'm doing that way so that I stay positive. All right, so I have minus 9 plus 18b. I add 9 to both sides, get 0 equals 18b. Anything divided by 0, as I get rid of that 18, is going to be 0, so it's safe for us to say b equals 0. And that's kind of what I want you guys to work on today. I'm just getting stronger with these algebra skills, these basic algebra skills, to make sure that we are good to go and well prepared for, you know, anything that's coming up, right? And I want us to kind of practice that, especially that radical stuff, because that's really important that we get that down today. All right, questions? You guys know where I'm at. Thanks for watching. I'll take care. You take care. We'll both be happy. All right, have a nice weekend. We'll see you then.